Good morning to one and all. Let us see in this session superposition theorem. Calculate the current flowing through 1 ohm resistor in the circuit shown in figure using superposition theorem. So we know that superposition theorem can be applicable to a circuit only when the circuit is having more than one source. Minimum 2 sources is mandatory. The 2 sources may be of voltage or current or mixture of voltage source and current source, but more than 2 sources. Minimum 2 sources required for applying superposition theorem. In the given circuit, there are 2 sources. One is this 2-volt source, another one is the 5 ampere source. So the circuit we can apply superposition theorem. Using superposition theorem, we have to calculate the current flowing through this 1 ohm. This 1 ohm resistance we have to calculate. Fine. First, let us see what is superposition advantage, disadvantage. If you see the advantage of the superposition theorem, now we are dealing only the DC circuit. If it is an AC circuit, if the source is having different frequencies, so the superposition theorem is the only method for solving such a kind of circuits. If you see the disadvantage, we have to take the sources one by one. We have to repeat the same thing for individual sources. That is a disadvantage. Fine. So now the question is calculate the current flowing through this 1 ohm resistance. So first we have to take the sources one by one. If you take the source case 1 as 2-volt source, this current source has to removed from the circuit. How do you remove? Always the current sources has to be opened. The voltage source has to be short. The reason is we have to include their internal resistances, because the difference between the ideal voltage source and practical voltage source is the internal resistance. The voltage source in series with the internal resistance is the practical voltage source, right? So to take into account of the internal resistance, the voltage source has to be short. Similarly, the current source, ideal current source is the one. Practical current source is one in which there will be some resistance, that internal resistance connected in parallel with the current source. So how do you include the internal resistance? Only when you open the current source, the internal resistance will be included. So the thumb rule is always the current sources is open and voltage source is short. Now let us see the explanation for the circuit. So first, this 2-volt source has taken. This current source is eliminated. Eliminated in the sense it is open. Fine. First, calculate the current I1 due to the voltage source alone. The current source is open circuited. The resulting circuit is shown in figure. As this 2-volt source polarity is plus and minus, the current flows like this, right? And it comes like this. The current flowing through 2 ohm branches like this, and this one like this. Then both the currents are coming like this and goes to us. So this is the, we can apply Kirchhoff's current law here as well as here. These two are the nodes, pair of nodes. Fine. Now, what is the current in the 1 ohm branch when this 2 volt is applied? So very simple circuit. So you can calculate the net resistance, and this voltage divided by the resistance will be the current delivered by the source. Using the current division rule, you can easily calculate the current flowing through the 1 ohm resistance. So the total resistance is 2 parallel with 1, these two. So 2 parallel with 1 is nothing but 2 by 3 plus 2 ohm. So it is 2.667 ohm. So if you apply the current division rule, or current flowing through this I1 is nothing but 2 divided by opposite resistance, 2 divided by addition of these two resistance into the source current. Source current we have calculated is 0.75. So the current flowing through I1 is nothing but 0.5 from B to A. That is most important thing we have mentioned here. Because next we are going to calculate the same 1 ohm branch by using this current source. In that case, the voltage has to be short. Look at this one. This is short. This one is applied. So the current, so these two parallel, right? This one is also, all the three are parallel. This resistance and this resistance 2 ohm, 2 ohm are parallel, again 1 ohm also parallel. Fine. You can calculate the current flowing through this 1 ohm resistance, any of the methods, but I can apply easily current division rule. So the value of the current I2 also I calculated, it is 2.5 from A to B. In the previous case, this is the direction. The second, when the second source, I mean 5 ampere is applied, the current direction is this one. Right? Both the currents are opposing each other, so that the net current flows through this 1 ohm resistance when both the sources are applied simultaneously is 2 ampere. This is the answer. Because the previous one is 2.5, this one is 0.5. Both are opposing. You have to take the difference. It is 2 ampere from A to B. Because A to B is the higher magnet. 2.5 ampere is the higher magnet compared with the previous one, that is 0.5. Right?